Hello friends, welcome back. Today in this video for the subject fluid mechanics, unit 2 pressure and fluid statics, we are going to see a derivation determination of metacentric height of a floating body. That is, the aim is to find out the value of metacentric height, a small derivation for a ship model. Now let us see the derivation. Now, as we have discussed in the previous videos that the point of action of weight for any body is the CG point. So, this is the weight of the body acting in the downward direction. So, similarly, the buoyant force Fb is acting at the center of buoyancy in the upward direction. Now, assume a weight, that is a movable weight, is placed on the deck, that is W1. A movable weight is placed on this deck on a floating body. Now, assume W, capital W is the total weight of the floating body or the ship, and W1 is the movable weight. So, now if what happens if we move W1, that is the movable weight, at a distance of x. You can see this is the distance x. The W1 weight is shifted to a distance of x towards the right side, right. So, in that case what will happen, the CG point, now this CG point and point of action of buoyancy. So, this part will get shifted to the new positions, that is G1 and B1, and it will have a inclination of an angle alpha with the new axis formed. So, this is the alpha formed. So, initial vertical axis is the point where the CG acts, and the new axis formed is the G1, that is the shifted CG point and the shifted B1 point. Now, let us see the analytical method. Now, the weight W1 is moved transversely through a distance x, so that the body tilts along a small angle and attains a new equilibrium position. So, the angle formed is alpha and measured with respect to the main vertical axis. Okay, you can see here in this diagram. So, the movement of W1 through the distance of x in the right direction changes the axis, that is the CG point, from G to G1 and the center of buoyancy from B to B1. So, under equilibrium conditions, what we have, due to change in position of W1, the movement due to the change of G to G1 will be equal. Okay, so, this movement will be equal, G to G1 and B to B1. So, for equilibrium condition, we can say the weight acting in the downward direction is what? X into W1, X into W1, and W into GG1, W into GG1, right, and W. So, that is equal, what we say, this movement. So, W into GG1. So, GG1 is the restoring couple, and W1 into X is the moment caused by the shifting of the movable weight. So, GG1, you can see GG1 is equal to GM. We'll just see, I will show it here, GM into tan of alpha, okay, that is GG1, okay, simple trigonometry, simple geometry, and now this GM value. So, GM is called as the metacentric height. This is the metacentric height, that is GM into tan of alpha, multiplied by the weight. So, that is the restoring couple acting to counteract on this W1 into X. So, what we get the derivation for GM, that is the metacentric height, GM is equal to W1 into X upon the weight of the ship into tan of alpha. So, this equation, once you know the weight, the displacement, distance, the self weight of the ship and the angle of inclination, we can find out the metacentric height. So, which is the G into, that is GM value. So, this is the derivation for to determine the metacentric height. These are the references. Thank you friends. Thank you very much.